Hello everyone. Today I'll be presenting a small project that me and my friend Alok Das and myself Abhishek Nayak have created, which is based on the commonly known topic retrieval augmented generation. This is one of the topics that involves LLMs. Okay, let's get right into it. Now, the main technologies that have been used were in the backend Python we have used FastAPI, ChromaDB, Llama CPP, and LangChain. For the UI, we use JavaScript with the frameworks React and ES6. Now, the objective of the project is to show the internal working of RAG. Many aspects of what is in our project is usually hidden from clients. So this is mainly for educational purposes. So you would take our project, take a subset of it and work on top of it to create something like a production ready project. Now, before we get into what exactly RAG architecture is, we just need to know one thing. How exactly do we know what text would be used to answer a particular question? Now, texts of any sort, whether it's your query or a particular text from a document, are stored in the form of numbers. If you have two numbers and you want to know how close they are to each other, what would you do? You would do some kind of a distance measure. In RAG, we usually use cosine similarity. There are other methods like Euclidean distance, but in this we use cosine similarity. And what do we do? Once we identify, let's say this particular text is the closest to our query, we have identified that this text that we have chosen is the most likely one to answer the question that we want. That is basically the intuition of how this RAG architecture mainly works. Now, let's go one by one. Our RAG architecture can be split into two halves. One is the uploading of the file and one is the asking of a question. When we upload a file, we don't just store the file as a single document, we store it as chunks. Why do we do this? Let's say I have two books. One of them is related to cats, one of them is related to dogs. If I were to ask you a question, which of the books gives me the answer to the question, what is the staple food cats have? Which book would you choose? You would choose cats. But what is the problem in that? You still have to go through the entire book to find the answer. Instead, if I tell you in the book related to cats, if you go to page number 10, there's a topic known as staple food for cats, then it becomes more clear. This is basically a kind of intuition of a way to understand why we do a chunking to the documents. This is to make the selection of the documents better. Selection of the chunks to answer the question better. Now, we take these chunks, we embed them. What is embedding? We basically take these chunks and convert them into numbers, into an array of numbers. All of these chunks are embedded chunks are then stored in a vector DB. That is basically the first flow. Next comes asking a query to the vector DB. We take this query, we make sure we use the same embedding model that was used to embed the chunks and embed the user query. Now what do we get? We get a set of numbers that correspond to the user query. We also have the chunks in the vector database. What we do, we take a distance measure, say cosine similarity, between these two, and then whatever value we get, we arrange the chunks that are retrieved in ascending order of cosine similarity. Which means the lesser the distance, the more likely the information we need is present in that textual chunk that has been retrieved. Then what do? We take these chunks, let's say the top chunks. In our demo which we have used 5. You can easily configure it using the config file. Let's say we took the top 5. What happens next? We take these chunks, these top chunks, and just feed it to the LLM. the LLM part of it is just the last step. So what do we do once we have these chunks, and how do we feed it into the LLM? LLM already has some information based on which it was trained. All we have to do is very simple. We say, do not give a response based on whatever you know. We are giving you this context, these 5 chunks. To answer the question, this user query that we have given passed through this pipeline, how would answer this user query based on whatever context we gave. By doing so, we are just asking it to follow a particular instruction instead of asking it to figure something out by itself. All it has to do is fetch whatever information is relevant to the query and give an answer, a natural language answer. This is basically how the RAG architecture works. Now, here we will see certain pages. We will get to that once we have our live demo. Now, the difference between usual RAG systems is that in our case we are displaying not only the response, but we are also using the chunks which are fed into the LLM to create the response that is wanted. So if you see below, there's a chunk 1, then the chunk 2 will also be present. So there are 5. We'll see the rest in the live demo. Now, the good thing about our backend is that it is completely detached from the UI. What do I mean? We have written it in Fast API in such a way that all we need is for the UI to hit these endpoints. So whatever UI you create, as long as you hit these endpoints in the correct manner, we'll be able to run the same pipeline using any UI, any framework that you have written. Okay. Then, now, the backend has been written in a very configurable manner. I've written a command line script in such a way that as long as you load this config, you'll be able to set all the values, and based on how you want to do the chunking or the content or the other LLM related parameters, you can just change them and rerun it. Now, I will not go too much into details, that is for later. But one thing I would like you to notice is that there is a prompt template sitting there. Now, the reason why, this is where I'll come to the reason why we use Llama CPP as a to locally run this, because if you were to use a server based approach, you would not get to see this prompt template in the flow, but in this case the prompt template can be seen here. Now, why did I choose these libraries? Now, the reason why I use ChromaDB, obviously before that all of these are open source. You can read up their documentation, very well written, especially ChromaDB is foolproof. The thing about ChromaDB is also that you are able to do a kind of filtering that does not involve this cosine similarity related stuff. This will be good for future upgradations. You can also implement a kind of role based access as well because of this. Why did we use Llama CPP? One, it is easy to run GGF models locally, and as I mentioned before, it is also to show the prompt template in the pipeline. Now, I myself, when I do testing, since I don't really need to look at the prompt template myself, I love using Grok API. Most of the servers are in US. You can easily access it, very easy to read documentation, and it's OpenAI compliant. You can get answers in seconds, but you will not be able to see this prompt template, which is why I haven't used it. Please do try it. Now, LangChain, it's a very standard library. This is what we have done to load documents and to do the chunking. The reason this is used is because most of the modern day libraries like Llama Index use LangChain. So I just went to the source and used that for the chunking. Now, what are the improvements planned? Now, as I mentioned, in the LLM, we give it an instruction saying, this is the context, this is the query, Based on this context, see if you can answer the question. Now, if, based on the tone at which we ask it to respond, the response will be different. So if I were to say, okay, give me a very, how do I say, narrative answer, then what happens? You will see a huge response like this, a huge response. So currently in the prompt template, I believe, yes, enthusiastic, narrate the answer. If you see, it is given narrate. Now, if I were to ask it to give a very concise and direct answer, it would probably give the answer in just one line if it can. So we can make this part of it configurable by just doing some kind of a string formatting. That would be it. Thank you. Next would be the live demo.
Now that my friend Abhishek is done with the theoretical part of things, I'll be showing a live demo of the RAG pipeline which we built. So we have a text box here where we can give the query. But first we have to upload a file which will be split into its chunks, and when a query is fired, it will find the nearest or the most similar chunks to that query and feed it to the LLM, and the LLM will use those as a base to give an answer. So I'm uploading this genuine student requirement. So it contains a lot of information about me, and it's successfully uploaded. And if you press the list files, you can see the file has been uploaded, and you can press delete to delete it. And I'll just show you that functionality as well. So it's deleted now. So if you click the list files now, it's not there. So I'm uploading it again. So I'll be giving it this query. How many years of work experience does Alok have? So the LLM has given me an answer. Alok is a software engineer with 2 years of work experience. So these are the chunks used by the LLM to get the answer. So this is the first chunk, and this is the second chunk, this is the third chunk, and this is the fourth chunk, and this is the fifth chunk. So we are using 5 chunks now. We can configure it to use as n number of chunks or even less chunks. In terms of further improvement, we are planning to add a toggle so that we can switch the LLM's answer in between narrative and concise mode. Thank you. That's all for the presentation. Thanks for watching.